Alright, lesson 5, angle relationships. Learning goal. When you're finished with this lesson, you should be able to describe or define and sketch each of the following angle pairs listed and problem solve with justification. We got adjacent angles, supplementary angles, vertical angles, linear pair, complementary angles, and angle bisector. So some terms. Adjacent angles. They are next to each other. They have a common vertex and no common interior points. So example, angle 1 and angle 2, they're next to each other. They share this vertex here. And 3 and 4, they share this vertex and are next to each other. Those are adjacent angles. Vertical angles are two angles whose sides are opposite rays. So they're kind of made up of the same lines. So you notice that this is a line and this is a line. And so opposite angles would be the angles in between those. They are the same. So opposite, vertical. So those two are the same, and also these two are vertical angles. Complementary angles, they are angles that add up to 90 degrees. They don't have to be next to each other, like this A and B. Those are still complementary, even though they aren't next to each other. This one, angle 1 and angle 2, you can tell easily that they make a right angle, and they add up to 90. Supplementary adds up to 180. They most of the time look like this, but again, they don't have to. So complementary 90, supplementary 180, and those two don't have to be next to each other. Adjacent angles have to be next to each other, share a common vertex. Vertical angles are opposite each other. They have to be made up of the same lines. So our diagram. I want to know if angle PAL, so PAL, this angle right here, I want to know if that and LAM, and this angle, I want to know if they're adjacent. Are they next to each other? Yes. Okay, I want to know if PAO, so PAO, this angle right here, and MAM, this angle here, I want to know if they're vertical angles. Well, one of the things I look at is, well, do they look the same? In this case, not really, but let's double check. They need to be made up of the same line, so here's a line. You notice if I try to make a line here, I go crooked. So that is not a straight line. So no, those are not vertical angles. They're opposite each other, but they are made up of the same lines. And again, PAO, this angle here, and NAO, this angle here. They want to know if they're supplementary. Supplementary means 180. So pretty much, does 106 plus 74 equal 180? Yes. Also, you'll notice this line is, they're a linear pair, so they also have to be supplementary. Alright, on the bottom, it says mark DOE and its vertical angle as congruent angles. So angle DOE, that is this one right here. I want to know which one is vertical from it. So I have this line and this line that make up that angle. So I know if we're talking about this angle is its vertical angle, it's congruent, it's the same. So that angle here has two names. I'm going to call it angle AOB. You could also call it BOA. Then we will mark angle AOE. So AOE. And its vertical angle as congruent angles. So here again, I got this line and this line, so I'm going to extend those. So this one goes up to here, this one goes down to here. I'm talking about AOE this angle here, so it's not going to be the smaller ones, it's going to be the bigger ones. So I got this angle across from it. That also has two names. It's got DOB. You could also have angle BOD. And the last one, name a pair of complementary angles. Again, complementary means 90. Well, I know if this angle is 90, this one has to be 90 because I have this line, and lines have to be 180. So I know for sure, oopsies. I know for sure that this is 90, so I'm gonna go with this angle right here, and I got two. It says name a pair of complementary angles. So I'm going to go with this angle and this angle. So this first one, angle COB, could also be angle BOC, and angle this one, BOA. Could be AOB as well. So that is those angles. Linear pairs. A linear pair is a pair of adjacent angles, so next to each other, whose non-common sides are opposite rays. So they share this common side, right? That's in both angles. So the non-common side are the ones that make the line. Okay? So angle 1 and angle 2 are a linear pair. Down below it says angle ABC and angle DBC are a linear pair. The measure of angle ABC equals 3x plus 19. Measure of angle DBC equals 7x minus 9. What are the measures of angle ABC and angle DBC? And we need to justify again. So I'm just going to draw a quick picture. Up above, I know B is in the middle of both of these, so that has to be the vertex, and then from there I'm just going to fill in. So I got angle ABC and angle DBC. I already got BC, so D has to go over here. Okay? And we'll make this colorful. ABC is green, and DBC blue. Alright. So I gotta somehow get x's involved. Well, I know that the measure of ABC plus the measure of angle DBC has to equal 180. I know that because it tells me in my instructions that it's a linear pair. So we got a definition of linear pair. I know that it adds up to 180 because linear pairs are supplementary. So we're going to go and supplementary. Okay. Now I'm just kind of doing what we've been doing. Substitution. So ABC, 3x plus 19. DBC, 7x minus 9 equals 180. Again, substitution. Now we're just going to simplify. 3x, 7x, 10x, 19 minus 9, 10. My justification is simplifying. Then we're going to subtract. And one last step. Oh, I lied. A couple more steps. Divide, so I get x to be 17. Now remember, back in the problem, it asked me what are the measures of angle ABC and angle DBC. Okay, I'm going to go right here. I know ABC is this one, and DBC is this one. So I'm going to plug in my 17 into x and those. So I'm going to plug 17 in for x. And I know 3 times 17 plus 19 gives me 70. Plug 17 in for x here. So the measure of angle DBC, 7 times 17 minus 9 gives me 110. Do these in the identical 180? Yes. So these are my 2 angle measures.